So, getting started for the day, I want to introduce our opening keynote, who kind of came to us rather fortuitously. Ben Kellie is a graduate of Ohio State and now lives in, is it Outback, is that fair to say? Outback of Alaska? Oh, he's a city slicker in Alaska, but does some work in the Outback. And he and I were having a conversation about maintaining culture as you grow and just encouraging your teams towards self-organization. So we're really excited for his experiences that he's going to share with us. So please welcome Ben Kellie.
Cool. Appreciate it. Hey, good morning. Give me just 1 second to get set up here. All right, let's start again. Good morning, everybody. How's everyone doing? Cool. Well, I'm thrilled to be here. I know it's going to be a great conference for everybody. And I've been in this room before, but mostly, as a student. So it's very fun to be up here and get a chance to address such a cool crowd. So, good morning. My name's Ben Kellie. I'm from Alaska, and this is me. I'm the dapper young man in the fanny pack and all camo standing on there. It's 90s stuff, right? I was born and raised in Alaska. My dad was a bush pilot. I grew up there, and we flew groceries to remote areas off the grid. We flew building supplies, four-wheelers, everything you might imagine. And there's over 150 communities in Alaska that are entirely isolated from the road system. And so you have to kind of think about that entirely different perspective. They were relying on us to bring the things they needed to survive past what they could take out of the ground and out of the woods. I've done quite a bit of bouncing around. This is my slightly circuitous map. After getting an undergrad degree in engineering in Alaska, I came down here to the Ohio State, go Bucks, and got a master's in mechanical engineering. After that, bounced out to California, up to Seattle, down Louisiana, out to Florida, and then finally back to Alaska. So what was going on during that time? After grad school, I got a job at SpaceX. They were building a West Coast launch site, and I was fortunate to get in as a very green and very terrified young engineer during a very critical time building that pad. I worked my way up to pad lead engineer, and this was our launch that went off in 2013. So we did everything from on the pad. There was about 8 engineers. We got all the design done. We worked with a big team of technicians to get everything built, and then we tested it and operated it. After that, I bounced out to Cape Canaveral, and I was working as the barge lead engineer. So this was the landing barge that they land the first stage on. And so I helped with the initial development, test, and operation on the first landings, landing attempts, as the barge lead engineer. Now, my most important title, I'm #1 cool dad. I moved back to Alaska after the barge project and started a business with my brother. That's the side gig when I'm not changing diapers. And we have a company called K2 Dronotics. So K2 Dronotics is combining our early pilot expertise, flying around remote Alaska, with our engineering backgrounds. How can we go to places of low infrastructure and bring back better data that lets people develop things more intelligently, report on climate change, and just get signals back that were otherwise too expensive or impossible to get back before. So kind of a quick example of that. It might be a little hard to see, but all of the surrounding area here, that's satellite imagery that they had before. And then this is our data laid on top. So it's a huge jump from roughly 2 feet per pixel to about 1 inch per pixel. And it's able to be got in for roughly half the cost of other methods. We're also pushing UAVs off the grid. We're flying drones beyond line of sight with the new federal program that lets people work with institutions like universities to do this. So we're working on things like package delivery, off-grid communications, and ways to kind of close that circle and get last mile infrastructure in place autonomously. We've also just started a new company called the Launch Company. We're taking our launch experiences, having our 2 principals having been a part of building over 8 sites and all 4 orbital landing sites in the world, and we're kind of deploying that out in a fast, efficient, lean way to multiple small rocket companies that are trying to get to launch faster. And so that's my background, and obviously not me on the moon, but Definitely a very fortunate person. And so you might be sitting here thinking like, cool story, bud, but so what? What does this have to do with me? What does this have to do with lean? And really, you're all lean experts, or you're working to become lean experts, or you're employing lean and agile methodologies. I'm just a person who has gone through a lot of very strange and very horrible projects that could have used these methodologies. So what I have is perspective, and what I have is some lessons that I'd like to share. In other words, I'm going to try to tell you what not to do. And what I've kind of found is that this what not to do is really helpful, because you don't want to go and reinvent the wheel and go down the path we've gone down. But we've been fortunate to work on some really cool things with high stakes, big budgets, not a lot of time to do it. And we've learned some cool things along the way. And when I was kind of reflecting, thinking to myself, what is interesting to share with an audience like this, I realized there was a lot of parallels between my early experience as a bush pilot and what we do now. And so we kind of worked on these 5 tenets. Alaska bush pilots live lean execution. We make our best plans and we adapt to them. We kill our ego so that we don't kill ourselves. We use constructive constraint. We don't think outside the box. We build a better box based on customer data, real world weather, all the things that are coming towards us. We do the unglamorous work, AKA the work. It's not enough to be the idea person, right? We get out there and we're actually having to do it. And then, of course, number 5, never panic, always stay rational. So there's this really great old adage that kind of ties all of this together. I don't know if you've heard this before. You can be an old pilot or you can be a bold pilot, right? But you can't be both. And so this is a photo of my dad and I flying past a volcano called Mount Redoubt, and he was very fortunate to be an old pilot, and I guess I was fortunate too because I was flying in the right seat with him. So really, the idea is just like running lean projects being a pilot. Every day you get in the cockpit, there's this inherent risk you're taking, right? You know what it is. You're going to leave the ground and you're going to go fly through these mountains in the middle of nowhere, and you're going to try to execute some mission. You're all trying to drive a team towards the goal. The point here is that there's some inherent risk level in everything that you do. There's inherently a risk getting behind the controls. Why add unnecessary risks that don't add any further reward? You know, things like not checking the weather, pushing hazardous attitudes, and going beyond what's safe and what's normal just for some sort of ego trip adds a ton of risk, but there's no added value because at the end you still need to land and you still need to deliver the product. There's no reason to go begging for trouble. So let's flip this on its head and let's talk about being bold. My first project out of grad school as a very green and scared young engineer was the Vandenberg acoustic water system. So rocket launch sites have these huge water systems. We can fill an Olympic-sized pool in like 5 minutes, which is just a ton of water. And we essentially have this old 1960s system on site, and they're like, dude, just hook into that and put all these new valves on the front end and design all the nozzles, and then let's go, let's make it work. And it's like, great, that sounds awesome. Let's definitely do that. But then, you know, we broke every rule along the way. We were super bold. So we flew by the seat of our pants. There was no time to make a plan because we have to get to the end. I mean, come on, we have to do this, right? Just get out there, get it done, get it going. We embraced ego and hazardous attitudes. We said things like, this can't fail. It absolutely can fail. In fact, as I'll show you on the next slide, it absolutely did fail. I was very much a part of that. We thought outside the box, which seemed like this really great idea, right? Like, oh, let's take an entirely new approach. This is what we're going to do. But that entirely new approach was not based in our very persistent reality, right? Like, it was very creative, but it ends up like not in the right ways. We didn't build a better box. And then, of course, we also put off the unglamorous work, the detail work, is this really gonna work? There was lots of planning and lots of conference room talks and lots of drawings, but there was very little small tests that would have cut down a lot of risk and given us some early failures to iterate back towards success. So we put off all this testing down the road. We built the thing, we're like congratulating ourselves, me especially, and then we got down the road. And this happened. I blew up the entire water system and washed out 2 roads. Just, yes, let that sink for a moment. So one minute you're standing there and you're very happy and you're proud and you're like, look at this glorious thing I've built. And the next minute you're standing around a sinkhole with the vice president of launch, the site director, and your direct boss thinking very much about handing in your resignation, moving back to Alaska off the grid so nobody will ever see your face again. This was like a few days before our first launch, by the way. So what did we do wrong? I mean, we're very smart people. We were at SpaceX, by God, right? But still, this was the result. And so what we did wrong was that we were very bold in this case. Now, just to bring this little story full circle, we did get it fixed, we did get it done, and we got the launch off successfully. So everything was great there. But that took even more work and even less time to get there. And we only had one data point. We knew one way it could fail, so we fixed that. But there was endless other ways it could have got us as well, right? So we're always told to be bold. Strike out, try new things, take a different approach. Well, that's true, but it has to live within our reality. So let's compare bold attitudes to old attitudes. Attack and charge ahead versus laying your best plan and adapting. I promise you, challenge will come your way no matter what. Don't go begging for unnecessary trouble. Saying things like we have to succeed, kill your ego instead, because you don't have to succeed. There's no mandate from above that says you're going to be successful. In fact, the odds are actually against you depending on the type of risks you're taking. These are actually hazardous attitudes that the FAA warns people about specifically when they're training to become pilots. Things like, I can do it, macho, thinking the rules don't apply to you, magical thinking, being kind of just divorced from reality and how you get from A to B. Thinking outside the box. Thinking outside the box is great, but it has to be constrained within reality. So another way to say it is build a better box. Get out to your clients, get out to your customers, whoever your stakeholder is, and bring that data in early and let it drive what you're trying to do. And then, of course, we all know the ideator, the person who wants to, be in all the meetings early on, and they want to say, but what if this, and what if that? But then it comes time to harvest the grain, and before we make the bread, and all of a sudden they're super busy with other ideating, and they don't want to come and help you anymore. Do the unglamorous work because the devil lives in those details. Without going into too much detail on that project, if we had checked 3 things that we just assumed were going to work, because, they have to work, this is how this works. If we checked those 3 things, that road never would have washed out. We didn't live in the detail. We were too concerned from getting from A to B. So let me put this in bush pilot terms. Who would you rather fly with? A pilot that comes screaming in, no fuel, the weather's failing, maximum crosswind, they put it down, kind of bounce around and roll in, and it's like, wow, that guy's a hero, holy smokes. Or the person that is sipping coffee in the airport lounge and never took off in the first place because they checked the weather and their pre-flight examination showed them there was a mechanical issue and they knew that it was better not to push the envelope and just to stay. That's old versus bold. And a lot of times we reward that bold behavior of saying, oh yeah, wow, look what this person did. It's like, well, that person just took a bunch of unnecessary risk for absolutely no reason. And they added nothing to the reward that we got out the other side, which was landing safely and going home at night. So what I'd like to do is just jump in a little bit deeper on each one of these points. So let's talk about the SpaceX landing barge a little bit. This was a really cool project to be a part of, and it was this idea that rockets should be reusable, and they've now achieved that. They're reusing these rockets, relaunching them all the time. But it had to start with this experiment of, let's put a barge underneath a rocket that's gonna land. What could go wrong, right? How's this gonna work? And you have to think about another little piece of pilot advice, which is, when do you land an airplane? Does anybody know when you land an airplane? Does anybody want to take a guess?
Before you run out of fuel.
What was that?
So before you run out of fuel.
Oh, yeah, that's a good time. Definitely. Yeah, I like that. I will accept that answer. I think that's better than my answer. My answer is before you take off. So you need to know where you're going to land before you ever get into the air, before you're committed. Because as I said when I did my first solo flight and the wheels off the ground, I was like, I'm committed now to myself alone in an airplane. So you need to lay your best plan and then fail continuously forward. So the way SpaceX did this was they were bringing their rockets back and hovering them over the ocean for months. And then they finally were like, well, we seem to have that down. Let's stick a rocket or a barge underneath the rocket and see what happens. And this is what happened. It smashed into our barge and blew up and burned for many hours. So there was just one step left, right? Like stick the barge under the thing. But it's never that easy. And so we had this really great plan, stick the barge under the thing. But then we had to adapt when the thing exploded and rained fire and brimstone over our beautiful creation. And so to put it in Alaskan terms, if you were going to mount an expedition and you were going to climb Denali, which is the tallest mountain in North America, and it's in our home state, wouldn't you want to like test your sleeping bag in the backyard? Like, wouldn't you want to like maybe see if your air mattress works? Wouldn't you want to decide if you even like sleeping outside before just being like, I'm going up the mountain, right? And so what we did was we built this very lean barge, which I'll pop back here. All of these are connexes. So all our critical systems were housed in these CONTINOUSLY that when they inevitably met their horrifying demise, could be replaced on the ground, swung up with a crane, and plugged back in so that we could go again. And that is kind of the idea about making a plan. We had this awesome plan, and it made perfect sense, and really, really smart people signed off on it, and it did eventually work, but we needed that real-world data fed back in to kind of do the most important thing, which is kill our egos. Because we get this survivor bias. It's like, well, dude, we built these landing sites, or launch sites, and now we're building these landing sites. These are directly related, but they're not directly related. And in a case here, just because you've built a system inside one company, it has nothing to do with building that system in another company. In fact, it probably puts you at a disadvantage because you're more likely to make assumptions about what will work and what will not work, rather than going through a lean process and understanding who you're selling to and who you're deploying to and how to make it work and fit for them. So when executing on these things, we have to kill our ego. If we have an idea of how to do something and somebody questions it and we get hurt feelings, that's ego. The fact that we had built that launch site has no bearing on our ability to land a rocket. They're completely different. But survivor bias starts to trick us into thinking that they're not completely different. And we start to say things like, this has to work, this will work, I've done this before. But again, these are completely separate situations. None of that is true, as the exploded thing proves to you. So you can't simply cling to the thing that brought you here before. Taking it back to flying a plane, weather's gonna change every single day. Your fuel might get water in it that it's okay, I won't check this time, and then your engine goes out. All of those things are things you have to check every single time. Just because an approach worked before doesn't mean it was the right one. Maybe you stole it. I mean, we've had things where we just dodged a bullet, and it was like, great, but then you started to think, I'm invincible, I can't be shot. You can be shot. And so a great example is this. I was flying with my dad, and this is out over Lake Clark in Alaska, and we're flying along on this overcast but still beautiful day, turquoise water, big mountains, and we're just cruising along. I swear to God, 5 minutes after I took this photo, we lost an engine. And we went from pleasure cruise on a summer day to like, holy smokes, we're 500 miles from town in the middle of nowhere, we need to find a place to land. So that's how quickly these things can change. And my dad being very good at what he does, it was fine. But if I had been at the controls, I probably would have ended up in the lake. So, number 3 is build a better box, applying constructive constraints. We all love to pick on WEBVAN, it's super easy, and you better believe I'm gonna do it again. So WEBVAN tried to predict the future while working in the present. They knew online grocery sales were going to be huge, right? It makes perfect sense. Like, we all hate shopping for groceries. Like, the lines are long, like, people push you out of the way to get deals on things. I don't know what happens at grocery stores, but because I buy my groceries online. But WEBVAN was not the people to do it, right? We all know what happened. They raised a ton of money on this great concept. Investors agreed, this is amazing, we definitely want to do this. And they went out and they spent all this money on huge distribution systems, all this overhead, all these trucks, all these people. And then I think they got, 20% of the sales they expected to get? And they were getting a lot of churn and not repeat customers, and the whole thing is just gone. And now they're like the standout for the .com, well, them and pets.com, or like the standout for what not to do. What did they do wrong? Online groceries are now a thing, right? Like Amazon Fresh is doing it. Like, I think with Giant Eagle here, you can like do an order online and then you just go pick it up and they run out to your car. Kroger does it. What they did wrong was they tried to use a present model to predict the future. They didn't use what we use, which is this sprint methodology. Is anybody familiar with the Google sprint methodology? Somebody loves it. Thank you for your support. Yeah, so the Google Sprint book is essentially asking the question, is the juice worth the squeeze, right? Like, are you approaching this in the right way, and are you getting out the data, or are you getting out the result based on the data that you put in? So a great example would be like WEBVAN. They go around and you don't ask loaded questions. You don't ask things like, wouldn't you love to buy groceries online? Because people go, yes. And there's a great book called The Mom Test, which really gets to the bottom of this, where if you're building customer interview questions, you should really read this. Because instead of saying things like, hey mom, wouldn't you think it'd be awesome to have an iPad app that was like Twitter for dogs and they could use their little fluffy paws to swipe on the screen and stuff? She'd be like, yeah, honey, I think that's great. Like, that's really good. But she's your mom and she doesn't want to hurt your feelings. You don't ask loaded questions. Instead, phrase questions more along the lines of like, does your dog ever use your tablet? And if you get past that question, you're amazing, but that'll tell you pretty quick that Twitter for dogs is maybe a non-starter, right? So with WEBVAN, you can start to ask things like, how do you buy your groceries now? What do you hate about that process? And you have to approach it from this completely non-egotistical way. You don't want to drive people to your solution, because your solution might be really bad. You want to drive and find out what the solution is and then build that solution, right? And that's what we know about Lean. And I really recommend this sprint process book. We have 4 people, and we're doing projects in multiple locations around the country, in UAVs and aerospace and building launch sites. And so we have to be really, really efficient in how we deploy 4 human beings' time. And sprints are a great way to let us know, because every day we'll have a great idea. Oh man, we're gonna build an online drone training database. Oh, we're gonna build this specialized rocket hardware. It's like, that's so cool. And as engineers and as tech people, like, it is cool. And we get really married to this idea of like how cool it is. But does anybody else care? And do they care about the form that it's in? I mean, maybe not, right? But that's what this sprint process can help you get to the bottom of. And it's been very helpful for us, and it's helped us stay alive pretty much as a company, and how we approach our problems. So, number 4, doing the unglamorous work. This is the thing none of us really want to do because it's actually the work, right? Like, planning is awesome. So, take the SpaceX landing barge. It is so much fun to watch a rocket come into port, standing up, and like take some cool selfies, and like throw them up on Insta and be like, I did this, right? It really sucks to go to Louisiana in the middle of the summer where it's 100 million degrees and stand in a shipyard and watch 50 people weld this thing together. But you don't get one without the other, right? And the point of the unglamorous work is that that's where the devil lives. The devil lives in the details. Without going into too much detail on this, we had parts show up. We spent a ton of money, 7 figures, on these specialized parts for this thing. And they showed up, and it was my first day out there, and the shipyard foreman goes, hey man, is the spacing for these braces on the parts the same as the spacing on the barge? And I go, yeah, of course. Like, who would build something that the spacing wasn't right? The spacing was not right. In fact, the spacing wasn't even close, because the internal structure of the barge changes. There's all these ribs down it. You can think like a model airplane, but there's all these ribs, and then the hull is welded to that. And they change in spacing depending on what section of the barge you're in. So somebody opened up the plans, took one number off one spacing, and then built it down the entire length. Because they were very busy, and there's a lot to do, and I have to get this done. Okay, but now I have to figure out how to hook these things to a side of a barge where nothing works. And we got to figure it out, and it was not a big deal, but it's those sorts of things every day. And as a leader on big projects like this, one of my favorite strategies is to go around and just ask each person what they need. So go to the electricians who are pulling cable. What do you need right now? Go to the welders. What do you need? And just do these laps. And I was walking like 9 miles a day on a 50 by 300 foot barge, just laps, solving problems all day long. It would have been really nice to sit in like the clean, air-conditioned, nice office in LA, but I had a picnic table with like an umbrella and a laptop on a Verizon MiFi, and it was just sending emails and doing things like that, and then go check in with people. The unglamorous work for me has included everything from doing last-minute paperwork to going and buying paint to paint the X in the middle of the night to, doing all sorts of other things. And that's hard to maybe want to do with our ego, right? But it's exactly what's critical. You want to keep your teams deployed on what they're good at. That's why you hired them. I don't want to wire high power voltage. I want the electricians to do that. I don't want to fuse metal because I'll screw it up. I want the welders to do that. And so your job as a leader is to empower the teams that are around you and let them go and be their best. And so that's the real work, that interface work, where the idea meets reality is where things are going to break down and where you're going to miss things. Just like the acoustic water system, right? If I had checked how these valves worked, it never would have happened. But I'm like, oh yeah, valves, they open and close. Well, those valves closed really, really fast, and then pipes exploded. So it's true, but it's the how, it's the detail of where that information lives. So I want to walk you through a project we just completed. It was a year-long project, and it was wrapped up about 4 or 5 weeks ago. So this one's still fresh on my mind. And I want to I want to give the audience a chance to think about how we approach this, to see how maybe you can figure out how to step outside your own perspective on things and bring the unique perspective of your diverse teammates who hopefully have lots of interesting and different backgrounds to bear on things that maybe seem like peripherally related. So this is called the RSS. It's the thing the pink arrow is pointing to. It's this giant tower that's out on LC-39A. LC-39A is a super historic, really cool launch site out on Cape Canaveral that SpaceX took over around 2014. This is the pad that the Apollo missions went off of. This is the pad that the space shuttles went off of. And now this is the pad that SpaceX launches their vehicles off of, including that Falcon Heavy that went up. So this is an awesome pad with a bunch of really cool legacy. But when it was taken over, they've got this huge tower that needs to come down. This tower rotates on a hinge right there on the right side and on train tracks here so that that white area can come around and encapsulate the space shuttle to load satellites into its cargo bay, rotate away, and the shuttle takes off. Really, really cool. But it's 20 years old, it has no use of being on the site, and it's getting rotten from sitting out in the elements for so long. It has to come down. So the problem became remove the tower without affecting the launch mount that's like 75 feet away, and also do this right as the site is about to take its first launch and then be used every 2 to 3 weeks for the rest of the year. So coming in, coming out, not interrupting launch operations. And you have to remove all 2,350 tons of steel. Further, and this is an overhead view from Google Maps, you can see how close we are to the launch mount. We can only work within this overlaid pink box. So in this case, we have a very literal box that we have to work inside of. So this is a really tight spot, right? I don't know if anybody follows aerospace too closely, but SpaceX has another pad out on Cape Canaveral, which is pad 40. It's actually over on the Air Force side. And they lost that pad during a static fire issue that they were working to rebuild. So this was their equatorial pad. Like this has to work, and they're not gonna have a bunch of dorks taking down a tower, get between them and launching a rocket, right? Like that's just a complete non-starter. And so the best bids for this entire project were $10 to $18 million and 12 to 18 months. And I don't know, does that seem reasonable? Hard to say, right? I felt the exact same way. I was like, okay, yeah, sure. And NASA had a similar pad, so that what you may not realize is this has a twin pad just a couple miles away, which is 39B, because engineers are very creative people. It's pad A and it's pad B, and they're the same pad, and they launch both things. So NASA had already taken down the RSS on pad B, and there's a YouTube video of how they took it down. I was like, great. So I bring up this 40-minute YouTube video, which is a time lapse, and I just watch how they take it down. But they had some things going for them. Pad B was a dead pad. There was nobody out there. So in the entire video, people are like strolling around and like cranes are coming in and they're like stopping for coffee. And I'm like, well, this is not how ours is gonna be, right? And I called this, actually the guy who owns the shipyard where we built the barge, and I said, hey, you guys do really scrappy work. you move really quick and you have great results. Like, do you know any demolition companies? And he goes, yeah, sure. Yeah, I know a great demolition company. Oh, nice. Who is he? He goes, me. And I was like, no, are you sure you're a shipyard? He's like, oh yeah, we're a demolition company. I was like, great. And I said, how much to take down this tower? And he told me right there on the phone. And I'm not going to tell you the number yet. He told me right there on the phone how much it would be and that he could do it within a year. And I said, all right. I just have to pick at this a little bit. How do you know that? And here's what's great. He had already been out on site for some other work, and he recognized that this tower needed to go, and he just walked himself through it, figured out entirely how it was put together, and made a strategy in his mind just for his own interest. Which was really great for me. Because I'm a thermofluids engineer. I like those things. And I know structures because I'm a mechanical engineer, but it's been a while, and this is advanced structures because this is taking something down in a tiny little pink area, and which looks really tiny on my monitor, and doing it safely and on time and all of these things, not interrupting launch. So he tells me, and does anybody want to shout out a guess what his price was? Wow, very good. Yeah, 1.5. But then wait, how? So we committed to 15% of the cost, but the same delivery schedule. I mean, I don't expect you to yell that at me because the answer's kind of complex, but I do want you to sit there and think about it for a second, because really great companies had put in these bids, right? They had all this experience putting towers up and taking towers down. They knew exactly how to do it. They knew exactly what it was going to take, and this is the price, and this is the schedule, and here you go. But this crazy guy from Louisiana is going to do it for 15% of the cost? Explosives were not an option. That's what everybody's going to guess. Oh, you just blew it up. There were certainly days where I wanted to put C4 on the legs, turn in my time card, and just get the heck out of there. But I didn't want to go directly to jail, so we did not do that. What we did was, going back to these tenants, we made a really, really good plan right there in real time. He and I worked really well together. We're already on the same page. We approached problems in the same way. We bantered back and forth until we had the plan. And I'll tell you what the plan is. We're going to walk through this entire thing. The most important part and the hardest part is we killed our egos. His plan was really different and really interesting, and it's like that aha moment where you're like, oh, of course, like this makes so much sense. But then there's this huge chasm between that and getting it done where your ego can get you in a lot of trouble. We stayed outside of that and we said, does the math work? Does this plan work? Can we stress test it? And we did this within about a 1-hour phone call. We thought outside the box, or in this case, inside the box, to figure out how we could stay within that demolition area and only take down that tower and not take down anything else. And we embraced the unglamorous work. I was back at the picnic table. I was sitting in a rental car up on the pad, typing on this computer on my lap, hooked to Wi-Fi. We gave up the creature comforts to be out there on site getting it done. And of course, when things inevitably went wrong, and oh boy, did they ever, we didn't panic. We adapted to the conditions in real time. Because as my dad used to say, and he told me this at a very young age, we're flying along, and he goes, what if we lost, I was literally like 8 to 10 years old. He's like, what if we lost an engine right now? I was like, ooh, that sounds really bad. And I was like, I don't even know. I'm like, can't even reach the pedals. I need like 2x4s, you know? And he's like, yeah, what would you do? And he made me walk through it. And then his advice was, and this is very fatalistic, but very much within the line of how these pilots think, is like, well, whatever you do, don't panic. Because if you panic, you're definitely going to die, right? And I was like, yeah. And he's like, if you don't panic, yeah, well, you're probably still going to die. But maybe you won't. And I just remember kind of sitting there nodding and being like, that makes sense to me, right? Like, I'll take that maybe over the certainty, right? And so let me kind of pull the veil back and explain what we realized. We didn't just see a tower, right? This is a tower, but it's a purpose-built tower. This is a machine. It turns on a hinge. It's got rail cars. This is a 2,350-ton rolling, essentially robot with tiny little human operators inside that made it do whatever it wanted. So it has a purpose. That purpose is to load cargo into the space shuttle. So what does that mean? That means that there's 2 90-ton capacity lifting eyes in this bay. And there are these huge cables, and they're just hanging down, they're just sitting there. How is that helpful? Well, cranes can cost something like $4,000 a day plus mob and demob. We went and bought, well, we rented them, these air-powered winches. And then we ran our own pulleys, and we pulled cable up to those dogs, and now we have cranes. And those cost about $1,000 a month. So $4,000 a day versus $1,000 a month. So you've just cut over $1 million out of this. Then, what's great with these winches is that you can actually pull this entire tower inside out. So naturally, I think you'd probably say, yeah, take this tower down top to bottom, right? Like, just work vertically downwards to the ground. It's a little hard to see in this photo. Let me go back to this one. But you can't just work to the ground, because eventually you're going to hit this 75-foot vertical drop, and there's no more ground, and you're going to have this overspanned structure, and you've got to figure out what to do there, and we'll get to that. So we thought outside the box. What's great about the winches is we can position them for heavy lifts on these dogs, and then we can move to other lifting points within the tower, and we can just turn this tower inside out. We can totally strip everything out of it for almost no cost. How many people, does anybody have a guess how many people we had working, physically working in the tower to take things out? Lower. A little less than 10. Sometimes we would hit 10, usually it was around 7 to 8. We got as low as 3. So instead of just deploying all these teams, we instead said, Ray, you run the winch. Ed, you run the torch. And Kenwood, you help Ed and watch things. And then my job was to stay 3 to 4 weeks ahead of them at all times. So manage the real-time schedule, see where they're going, what sort of things were going to come up. And that's what we did. And a cool thing about working at a company, and at this point I was consulting to them, what was cool about working with a company like this is I called a decision maker there and I said, hey, what if we could get that tower down for like $1.5 million? And he goes, just do it. Okay, don't you want to know the plan? No, I trust you. I was like, ooh, that's bad. But then that's the ego part, is like, you would really pump you up to be like, wow, this decision maker trusts me. Instead, it terrified me. It's like, oh God, we got to knock this out of the park. Like, we really got to get this done. And so don't panic, right? So what was really cool about the winches also is that we could run them through the floor. So a crane would never be able to get under the tower. And this is an 80,000-pound lift. It's one floor of the entire tower coming down in one big piece. So instead of a bunch of time-consuming little lifts, we just did these huge lifts, brought them to the ground, chopped it up, threw it in dumpsters, rolled it away. NASA's smoking cigars and cackling happily because they get all the scrap value. And we just found a way to do that differently. So here's what we did. We hooked into these lifting dogs, and we hollowed the tower out. So you can see all that outside paneling has been scraped away. And what do you start to see as the outside paneling is scraped away? You see the actual structure of the tower. You see its bones. You see the skeleton of how it was actually holding it up. And this lets us plan ahead and see what's coming and doing this just-in-time design and delivery work. We then got to harder things, like taking the top off. The problem with taking the head off of it, is that that's where the lifting dogs are. So once that goes, we now have lost our advantage, right? But what have we gained? First of all, at this point, we've dropped something like, we've dropped hundreds and hundreds of tons of steel off this tower, so it's way lighter, it's under almost no stress anymore. And you can really see the skeleton of how this thing's put together. And what we were able to do then was use the winches from the top roof and pull all non-structural members. So I don't know if people are familiar with this, but some of these members here, and that's the sticks you see, and by the way, these are like this big around. It's just hard to tell in the photo. Not all of them take load anymore because the weight is off of them. So some are zero force members. So we can just clip those out right away and just get down to the core offering, or the core of what's left. Keep in mind that we still have to get the heck out of the way every time they want to launch a rocket. So we would get roughly 24 hours notice. There's our partially deconstructed tower with no head left on it. And I'm not joking when I say how closely coupled these things are, right? So what's something you got to think about? You can't have things partially disassembled when the big rocket goes by, because they'll end up elsewhere, and they turn into flying shrapnel. And so every time it's a full cleanup, it's making sure we stop at a place where we're engineering stable. And it was a challenge. It was a big deal. And remember, we can only drop things straight down off this tower. We've got maybe 30 feet on each side to kind of work. So then we got down to where it was just the frame, and we brought in a crane. At some point, you have to bring the crane in. But instead of 12 months, we brought it in for 2 weeks. Brought the crane in, picked down the rest of those skeleton structures, and then we were left with that overspan and planned a critical lift, which was a full 12-hour day. And when I say 12-hour day, it might have gone a little longer, of taking down, and this was the big piece that was on the railroad tracks. And we took down the floor and left the tower cantilevered. So now the nub of that tower is hanging off the other tower. And the way we save money is, another way we save money is we would go to the structural engineers, and they were the people who originally designed and built the tower in the 60s. They're still a company, they're still around, they have the original drawings. We'd say, can we cut the tower in half and like drop half of it to the ground and like leave the other half hanging off the second tower? And they would just look at us like, no. I'd be like, okay, but why? And they're like, it's just, I mean, that doesn't make any sense. I was like, well, I know that, but like, can you run the math and tell me that it doesn't make sense? And then sure enough, they ran the math, they're like, this is fine. And I was like, great. And then so we did it. And so it's continuing to just ask why, to get to, well, I understand that this is not normally what you see, but can we do it? And if they say no, just pressing why, data, show me why. And so we ended up being able to cantilever the rest of the tower. This piece right here weighed 104,000 pounds in one lift. And that was our most critical lift of the whole project. And we pulled it off safely. It was a really nice day, things went great. And then just a couple weeks later, we got it to where it stands now. So just down to the hinge column, everything else is gone. Customer's happy, and we were very excited to pack our stuff and leave because it was a very long project and it was a lot of hard work. So bringing that all full circle, always make your best plan and adapt. Kill your ego and be reasonable so your ego doesn't kill you. Use constructive constraints to build a better box to work within, whether it's for your clients or whether it's literally the box that you're working in on a launch pad in Florida. Solve problems quickly and do the unglamorous work because you're not going to run out of problems to solve. Just real quick aside, there's so many times I'll be running an engineering team and they'll be like, I'm 90% of the way there. I go, great, ship it. And they're like, no, I could really optimize. I go, I truly don't care. Like, give it to me. Are you afraid that we're going to run out of problems? I promise you there's more problems. Like, your job is already very safe. Like, let's get to the more interesting problems now. And then, of course, never panic and stay irrational. And that's what I have. Thank you. And I think we have a little time for questions, if that's right. I'm looking for Faye. She might have run out of the room. But if anybody has a question, you can jump up and ask it until she hustles me off the stage.
So how long was it, start to finish?
It was about 13 months instead of 12, but one thing we didn't bank on was that they'd be launching every 2 to 3 weeks, which they did and they executed on. So yeah, we pretty much hit time and we definitely hit budget and got out of there. Yeah, thanks for your question. Any other questions? Well, you can always catch me later too. I'll be hanging around the conference. Love to touch base with people and see what y'all are working on if there's any way to help. So thank you again.